Students, now we will be talking about the automated guided vehicles. The capacity planning actually involves determining the number and types of AGVs to meet the material handling. For example, for vehicle routing and scheduling, or for load size specifications and traffic management or control are the most important operational problems. So in our material handling, AGVs plays an important role. We need to remember that these are the programmable material handling equipment. We know that there were different characteristics that were involved in actually going for a different type of material handling equipment. Of course, we can have manual equipments, we can have some mechanized material handling equipment, and of course the automated material handling equipments as well. So AGVs are the ones which are like programmable. They are used for vehicle routing, scheduling, load size specifications, and even for the traffic management in your facility. Now, if you look at the analytical model, this model assumes the model for the AGV and that what would be the capacity and what would be the flow rate for a automated guided vehicle. We have one analytical model for it. This model assumes constant vehicle velocity. The basic equation to determine the number of AGVs required, for example, denoted by N AGV is as follows. So N would represent the number of AGVs required. That would be equal to D over C, where D is the number of deliveries required per hour and C is the number of deliveries per hour per AGV. So what is the requirement and what actual an AGV delivers in an hour is C. So the ratio of D over C will give the number of AGVs required. So the number of deliveries required per hour is the expected material handling load on a system. So how many deliveries are actually done in an hour, that will actually tell you the expected material load on the system and is usually estimated based on manufacturing requirements. This information is an input to the AGV model. So the number of deliveries per hour per AGV is computed as follows. So C is equal to 60F divided by T. 60 would be for the time. Here, F is the traffic factor and T is the total time per delivery per vehicle. So big T would actually represent the total time per delivery per vehicle required. The traffic factor actually represents the effect of traffic congestion, scheduling problems, and other inefficiencies. So we have actually estimated one factor F. What does it represent? It actually represents that how much traffic is there in your facility. What is the congestion level? कितना ज़्यादा rush करती हैं different facility, different vehicles एक path के ऊपर. Of course, it can create some scheduling issues as well as other inefficiencies like delays. So the total time per delivery consists of the loaded time, travel time, empty travel time, and the handling time. These are the three times which are actually important for a material handling process. You have a loaded time, you have the empty travel time, and you have the handling time as well. Handling time actually includes both the loading time at the origin and unloading time at the destination. So what is this? When the vehicle would travel, when it is loaded, it would be a loaded travel time. When the vehicle is empty, it would be the empty travel time after unloading. And the handling time would actually include the loading time at the origin as well as the unloading time at the destination. So the travel times are a function of travel distance and AGV velocity. So the total travel time T would be represented by L over V plus H plus D over V, where L is the loaded travel time in meters. If you remember the previous models which we discussed about the material handling equipment, the distance was measured in meters. D is the empty travel time distance. So L over V, and the last ratio, D over V, the last fraction. L over V would be for the loaded travel distance, whereas D over V is for the empty travel distance. V is the AGV velocity, meters per minute. In other words, you can say this is the speed of the AGV. So that would be represented by V, and H is the handling time. So what we have the loaded travel time plus the handling time plus the unloaded travel time. That would actually give me the total travel time. Students, we have seen the analytical model for AGV, that how would we actually know that how many AGVs are required, and at the same time, what would be the total time requirement for that AGV. That would be, of course, the sum of the loaded travel time plus the handling time plus the unloaded travel time. Thank you.